In this video, I am going to talk about GPS, which stands for Global Positioning System. GPS tells us where we are. It helps us track our location in a geographical space. But how the GPS actually does it? This is what I am going to talk about in this video. GPS involves two things in this process. First, we have a GPS transmitter and we have a GPS device, which is a receiver. The GPS was first launched in 1978 and was limited to United States military services only, to assist soldiers and military vehicles, planes, and ships to accurately determine the locations. Later, GPS was opened to civilian use by the US Secretary of Defense in 1993. Benefin was the first mobile developed in 1999 with GPS available in it. But nowadays, a GPS receiver is embedded in all the smartphones today. GPS transmitters are nothing but the satellites which are revolving around our planet. So there are many of them. But whenever there is a user who wants to track his location, then the four satellites which are nearby the user's device will come into picture in this process. The user who wants to track his location will be receiving some information from these four satellites into his GPS device. So what is this information that the user's device is receiving? The satellite doesn't send the location of the device to the receiver. It can't do so because there are millions of such devices wanting to track its location. So it has to send some common information to all the GPS receivers. Just like a satellite broadcasts TV shows commonly to all the households receiving it. In this case, it sends two things. First is the location of the satellite, and second is the time at which the signal has been sent. Only through these two information, the user's device is able to figure out its current location. The signal which will be sent is a microwave signal, and the speed of a microwave signal is equal to that of a light, which is approximately 3 lakhs kilometers per second. So now we know the speed of the signal. The GPS device knows the time at which the signal was sent from the satellite and also the time at which the receiver has received the signal. Suppose we call the time at which the signal was sent as T1 and the time at which the receiver received it as T2. The time difference would be the time taken by the signal in traveling the distance from the satellite to the receiver. The clocks in the GPS are very precise and are able to measure in nanoseconds. As the speed of the signal is very high and the time taken to travel the distance is very less, somewhere in nanoseconds, the GPS clocks have to be very precise to measure with such an accuracy. Before we move on, we need to understand that GPS tells the geographical location only in coordinate systems of latitudes and longitudes. And then there are some software applications like Google Map which helps us spot those latitudes and longitude coordinates on a map so that you can know exactly which country, state, city and locality is your location. Now we have the time taken to travel the distance and we know the speed of the signal which is being sent. So time into speed will give us distance, and this distance is the distance of the satellite from the user's device. In this way, we can figure out the distances of each satellite from the user. Let's call these distances as D1, D2, D3 and D4. Now we have this information. But how is this distance letting us know what is the location of the device? And this is how it is done. Let's plot a 2D graph. Let's keep it simple in the beginning, then we will move on to the 3D space. Suppose we have only 3 satellites in 2D space, which are located in different places. Suppose we take the first satellite. We know the distance at which the device is located from each satellite. So if we draw a circle, keeping the satellite as a center of the circle with the radius of that of the distance of the satellite from the device, then we have an idea that the device is located somewhere on the circumference of the circle. Similarly, if we draw a circle around the other satellite with the radius of the distance of that satellite to the device, that is distance d2, then there will be 2 points where the circles will be intersecting. It means we know that the device is located at either of the 2 points. because this is the point which confirms the distance for each satellite to the device, that is distance d1 and d2. Suppose we introduce the third satellite as well and draw a circle with that distance, that is d3. Then the three circles will be intersecting at exactly one point. As the device knows about the location of the satellite, say the xy coordinates in this case, then we can mathematically calculate the intersecting point of these three circles using trigonometric functions. Then the xy coordinate becomes the location of the device in 2D space. In a three-dimensional space, we have the z coordinate as well, and in place of circles, we need to deal with spheres. The three spheres will intersect at one point. Here we need to calculate the x, y and z coordinates of the point where the three spheres are intersecting. The fourth satellite is used to form another sphere to add more correctness in spotting the location of the device. In this way, the location of the device is identified by the GPS. GPS coordinate system, instead of x, y and z axis, it considers latitudes, longitudes and altitudes. Altitude is the measurement of height in space. There are many mathematical calculations done under this technique, which I have not covered in this video. My intention here was to cover the core concept of the working of the GPS. And I hope you have enjoyed learning this concept. Bye bye for now. Take care.